What if we have an expression involving radicals that involves both multiplication and addition? So for example, what if we want to simplify an expression that looks like this? What should we do? Well, notice that we cannot combine either of these sums inside parentheses. So we have one expression with two terms added to another expression with two terms. We multiply these as if they were binomials. So what will we have? We'll have 3 cube root 2 times 6 cube root 4 plus 3 cube root 2 times 2 cube root 3 minus 4 cube root 9 times 6 cube root 4 minus 4 cube root 9 times 2 cube root 3. All right, great. What does that work out to? Well, now we go through and do each of these multiplications separately. 3 times 6 is 18. Cube root 2 times 4 is 8. Plus 3 times 2 is 6. Cube root 2 times 3 is 6. Minus 4 times 6 is 24. Cube root 9 times 4 is 36. Minus 4 times 2 is 8. Cube root 9 times 3 is 27. Am I done? I'm not done. I've got to simplify my radicals. Cube root 8, though, that's easy, right? 18 times 2 plus 6 is 2 times 6. That hasn't got any perfect cube factors. 6 is 2 times 3. That hasn't got any perfect cube factors. 36, 2 squared times 3 squared gave me 36. That hasn't got any perfect cube factors. Cube root 27, oh, that's a nice number. That's just 3. Okay, so these radicals are not like radicals. But these two whole numbers are good. I'll have 36 minus 24 plus 6 cube root 6 minus 24 cube root 36. Subtracting, I get 8 plus 6 cube root 6 minus 24 cube root 36. Now, as you're working these, I really recommend writing out this step, just because if you try to multiply at the same time, you're very likely to drop a coefficient on the floor. And you don't want that. But other than that, this is pretty straightforward. It's the same thing we do whenever we multiply two sums with each other. Let me give you one of these to try. Multiply these two radical expressions and simplify your answer as much as possible. Pause the video and try this now. Okay, so I'll have 3 times root 2, 4 times 3 times root 10, minus root 5 times root 2, minus root 5 times 4 root 10. That'll be 3 root 2 plus 12 root 10. Combining these two radicals, minus root 10, minus 4 root 50. Root 10 I know I can't simplify, but off to the side here I'm going to simplify root 50. 50 is 25 times 2. So this is going to be 5 root 2. And if you didn't spot that 25 was a perfect square factor immediately, you could also go to the prime factorization. 4 times root 50 is 4 times 5 root 2, so it's 20 root 2. So I see I have two pairs of like radicals. This pair and this pair. Let's see. 3 root 2 minus 20 root 2. That'll be negative 17 root 2. 12 root 10 minus root 10. That's 11 root 10. And this is my final answer.